Hey folks, now I want to walk you through the rib feature, which will allow you to take a profile of any sketch and a second profile of any pathway and translate that down and around the path. So to show this, I want to show you an example of paperclip. First, let's go into mechanical design, part design, and I'll call this emulate rib. First thing I want to do, enter into sketch mode on, doesn't really matter which plane, but I'm going to use my front plane here. And for this one, I'm going to use it for my profile. So I'm going to make it just that circle, that little tiny circle that my cross-sectional area of my paperclip is. I don't know, probably something around 5 millimeters. If it's too big, we'll come back and change it. So making sure it's fully defined. So you can see here, I've literally pierced it right into the center of that origin. That way, when I cross back into my model, I can choose one of the planes that's directly going to intersect with that in order to sketch my pathway on. So I'm actually going to use the top plane for this. Enter into sketch mode. Now, notice this is my profile, so I'm going to zoom in there so you can see. But if you know where your sketch was, it'll help you make sure that your profile that you're drawing as your path is going to meet directly in that spot. So I literally want to take my first point and put it right there on the center where it's going to meet with the other sketch. Zoom out a little bit. So if I go to make the outside, first of all, we got to remember what our measurements were. So for this one, it was 15 in this direction, and then which way did we go? Kind of go this way, right? So if I hover over the end and pull away, if I click and pull, I can actually turn it into an arc right there. And then if I line it up, then I can get that tangency right there, which is pretty cool. And then I'm going to make sure I line this one up to get that tangency right there as well and lock in that horizontal relationship. Bonus. And then again, come back. I'm going to click right there on the corner and pull away. And that's how I'm going to make it turn directly into a tangent arc. And then, is this the end of my... Nope, I gotta go one more, right? All the way. I want to start to make, probably goes a little bit further. And then again, click and drag away. Place it where it turns blue so that I can get those tangencies. And then I do want to actually end at the exact same spot I started. And then I can hit escape to end my profile. So then dimension it. First off, I think 5 is probably going to be too big. I think it might actually be in inches. So let's check our units. If I go into options, our units would be under parameters and measures, units, millimeters. So it is millimeters. So we're good. This looks a little bit smaller than I expected, but probably just how I drew it. All right, so notice it crossed all of that. So I'm going to just reposition where I am. And notice that if you dimension, either from the largest in or the smallest out, it can help you kind of reduce the number of times you have to go through and manipulate your object. Okay, so let's make this radius be 3. And this radius be 4. And this one be 5. Then, so that one, obviously I was missing the horizontal constraint. So what I'm going to do next is just select all these lines. Actually, just 2 of them should work because the other 2 already have horizontal constraints on them. Go ahead, insert that horizontal, the final leg there. All right, so to finish off, I still need locators for these folks. So from that center point of my circle to back where the origin was, ooh, not on that angle, just to that horizontal line. Oh, now it got to the outside of my circle. I wanted it from the center point of the circle. Sometimes you have to try a couple times to get it the way you want it. There we go. All right, so I want to actually place that to be 10. And then finally, this last one here, 25. All right, so hopefully I have an ISO constrained sketch to make sure. I can double check down here at the bottom, solving status ISO constrained, yay. So looks good there, so I'm just gonna exit my sketch and double check to make sure that I'm not gonna overlap. Ooh, looks like I am. So go back to my sketch 1 and see what we did there. Ooh, my diameter of 5. I actually wanted that to be a radius of 5. So let's change that. You can either change this radius or like divide the diameter in half if you prefer. And no, that didn't work. I don't know. My diameter is 2.5. I think I was thinking it was my radius. All right, so now it does look like it's going to be constrained on the inside. Hopefully it doesn't overlap. We'll do a check. But if you jump over to the rib, while your first sketch is selected, that would be the profile. You can sketch it, select it over here in the feature tree. Your center curve is your pathway, so that's going to be my sketch 2. And if I preview it, know that it does. Let's zoom in and see if it's overlapping. Because we do want it to be close, but we don't want it to be like on top of each other. So dang, we are still overlapping. So let's go back into that sketch 1. And again, let's zoom out there. It's a screen. Instead, let's make this 2 as our diameter. And notice it's going to be angry at us because it's telling us, wait, that's not how you built it. Are you sure? Update. Yes, I want to update it. All right, so now if I zoom in, I hopefully see a little bit of a space in there. All right, so last thing I want to do is take this face right here at the corner and just kind of smooth it out a little bit. So if I select the entire edge, or I can select the face, right? And it'll select the edge for me. My option over here to do a chamfer will, or sorry, excuse me, to do an edge fillet will allow me to grind that just a little bit down. My radius here though, obviously it needs to be small because my radius of the whole thing is pretty small. And so if you do a preview, you can kind of see what it looks like. I'm gonna do the exact same thing on the other side. Notice again that edge fillet size was a 0.5 millimeter. And that way I would just kind of smooth that out a little bit. And on that note, let's save this and get it drawn up in the diagram.